Hello students, I am Mohammad Kamran Halil from YouTube channel The Physics Gurus. So today we will learn the physics in a different way. I will explain the basic concept of the physics animations, how to use those animation to make really very clear concept of the topic. The topic which I have selected today is related with the simple pendulum. This topic is related with the O levels as well as A levels. So we will start it from the very first website. Keep one thing in your mind that I have got the special permission from these two websites, and I am really thankful to them that they have granted me permission to use this animation in my YouTube videos. So the first one is the phet.florida.edu.sims, and this one is really a wonderful website. There are so many animations related with the physics, chemistry, biology, mathematics, and I love to teach by using these animation. And then the next one, the website which I will use the is the walter-fendt.de. This person has done a lot of hard work in order to make these animations, and it will make clear the concept of the students. So let me start. Simple pendulum or the oscillation. So the introduction, as we all know that the time period is a time which is required to complete one oscillation. So by clicking this ruler, we can show the ruler in order to measure the length. And then certainly we need a stopwatch, so we will place a stopwatch from this point up to this point in order to measure the time period. And then it is a periodic trace. Now this position at which this is placed, this is called as the mean position. This is marked as a critical mark as well. So when we will start the stopwatch, it means that the position of the pendulum should be at that point. It should be at the main position. So that's why I have clicked this one, the periodic trace. It will start the oscillation right from the mid, and then it will move up and down and right and left. So let me start. Now you can see that the length is zero point 0.7 meter, the mass is 1 kg, and the gravity is on the surface of Earth now without any friction. So we will start it. Now let's suppose that we will swing it from the angle of 60 degree, and now we will slow down. Now we will do that work in a slow motion. As soon as it will reach the main position, I will start the stopwatch. So this is 1/4 oscillation. Then it turned back to its main position, half oscillation, then the other maximum position, and then at this point, almost the time period is 1.82 seconds. So now this is the time period related with the length of zero point 0.7 meter. Now let we change this. We will pause it, and then we will stop it. Now we will change the mass. The mass we will change it from 1 kg up to 1.5 kg, and we will reset this. 1.82 was the answer, and then we will move it to the 60 degree again, and we will start. Now we can move this very slowly as well, so that we can measure the time period accurately. So now when it will reach at this point, start this. Okay, now we have changed the mass. Now let's see what is the effect of the changing the mass on the time period. So it has completed one oscillation. Let it go for the another one, and now when it will move to the main position, now I have started it. The previous answer was 1.82. Now let's see what is the time period after changing the mass from 1 kg up to 1. It is 1.81. Almost the time period will remain same. So there is no effect by changing the mass. So keep this thing in your mind. The first result which we have observed from this animation, that by changing the mass there is no change in the time period. So we will stop this. Now we will change the length. Okay, what we will do, we will remain the length at zero point 0.7 and the mass is 1 kg. Now we will change the value of the gravity. The time period is t that is equal to 2 pi under root L over g. So now if we will select the moon, and now we will play this animation once again, move it to the 60 degree. This is the amplitude. Let it go. Now we will observe that what will happen when it will place on the surface of moon, or where there is a less gravity as compared to the earth. So it went to the extreme position, then it will come back. 1/4 cycle has been completed. Now the half oscillation has completed. Now third fourth of the oscillation has completed. The previous answer was 1.82, and now we will stop it when it will move from the, that's it. So 4.44 seconds are required for the same length, the same mass, but the gravity has been changed. So it means that by changing the gravity, the time period will also change. So we will reset it. Let's suppose that we will take another, the Jupiter. Now let's see what will happen on the surface of the Jupiter. Conditions will remain same, 60 degree. And then what we will deduce result from this result. 1.12. So what do you think? The value of the gravity on the surface of the Jupiter is more than the surface of Earth, or it is less than the surface of Earth? The more will be the gravity, the less will be the time period. So it means that the gravity on the surface of Jupiter is less, is more than the gravity as compared to the Earth, because the time period is 1.12 seconds. So gravity and the time period are inversely proportional to each other. So we will stop it, and then again we will select it to the surface of Earth, and the time period will remain, the length will remain same. Now we will include the friction. Now let's see what will happen to the oscillation. 60. Okay, let it go. Now it reached to the 60-degree angle, and now on the right side you will observe that the angle start decreasing due to the presence of the friction. So it's not going to reach its maximum amplitude, so it start decreasing. So it reach up to this point. So it means that if there is some air resistance, then the oscillation will start decreasing. The time period will remain same. There is no effect on the time period. Let me check. What is the effect of friction on the time period? Initially the time period was 1.82 second. It's almost the same. The human reaction time error. So by introduction of the friction, the amplitude will start decreasing. Okay, now we will make it to the none, and now we will change the length. Now we have changed the length up to 1 meter. Reset. Here we go. The stopwatch will be at this point, and now the angle is the 60 degree. Let it go as soon as now start. Now we will observe what will happen to the time period when we have increased the length. Initially, zero point 0.7 meter length, the time period produced was 1.82 second almost. So now we have increased the length. So it means that the time period will increase. So it reached up to 2.16 second. Okay, now we will stop it. We will decrease the length from zero point 0.5. Now we will turn it to the 0.5. Now let's see what will happen to the time period. 50 and then 60. Let it go. So when we will decrease the time period, the length, the time period will also decrease. And then here we go, this one. So 1.50 seconds. So guys, the time period of the pendulum depend on the two factors. Number one, it depend on the length. The more will be the length, then the more will be the time period. And number two, the gravity. It is inversely proportional to the gravity. Now move towards the next thing is the energy related with the purely the O levels and A levels topic as well. On the left side, you can see the energy graph. There is the kinetic energy and the potential energy and the total energy and the heat energy as well. Because we have not introduced the friction, so we have to only concern with the kinetic energy and the potential energy. So what we will observe, no need for the time period because the time period already we have done it in the previous. Okay, now fix it at the 60 degree. Okay, we will slow down the movement. Okay, and now observe the graph which is on the left side. We will move it by step. Now at the main position, you can observe that potential energy is almost zero, but the kinetic energy is maximum. Because when it will move from the extreme to the main position, then it has maximum momentum, it has maximum kinetic energy, it has maximum speed, due to which its kinetic energy will be more. And now as soon as we will move towards the extreme position, now somewhere at this point it has the same kinetic energy and the same potential energy. So when we will move towards the extreme position, now it will stop. And when it will stop, it means that now its kinetic energy will be zero. And then it has the maximum potential energy. So when it will move again, it will stop and start moving towards the main position. Then you can observe that at the main position again the kinetic energy is maximum and the potential energy is zero. So now we will move towards the normal view and you can observe this. Okay, then the next one is related with the energy. I hope that you got the answer. That now we will move this slider bar towards this. Now we have introduced the friction or the air resistance. Okay, let's start. 60 was the initial position. Now you can see that there is a heat energy as well. Make it slow down the movement. So what is the reason of the heat energy? The thermal energy is the presence of the air. When the pendulum will strike with the air particle, it will rub with the air particle, and due to the rubbing, the heat energy will be produced. And there is one other change in the E total. So you can observe that in E total, the kinetic energy, the potential energy, and the heat energy is also present. So if we will decrease this and we will reset it, and lots of the heat energy is introduced. Now what will happen? 60, this is the amplitude, 15, 60, let it go. So the value of the heat energy increased as compared to the previous one, the animation, which we have already observed. And the other thing which we will observe in this animation, that it will slow down and it will halt very quickly because there is a lot of friction which is present. So it will stop in a quick time as compared to when there was no air friction present. and then it will become at rest. Slowly, slowly, it is related with the damped oscillation. So damped oscillation, the heat energy will be produced and the amplitude of the oscillation will decrease. And here we go. Eventually it will stop. Okay, ji. The next thing is related with this lab is the direction of the velocity and the direction of the acceleration. Already we have done this. So now acceleration. Acceleration is always directly towards the main position because in the simple harmonic motion we have observed that this is a motion in which the acceleration and the amplitude and the acceleration are directly proportional from the main position and always directed towards the main position. So we will move in a slow motion. So the acceleration is always directed towards the mean position. Acceleration depend on the gravity as well. This is the thing which we have to observe from this. So if we will move this gravity towards the on the surface of earth, then the acceleration will decrease. And if we will change the value of the gravity, because the acceleration is the gravity as well on the surface of the Jupiter, and then we will play it in a slow motion. So on this surface of the Jupiter there is more gravity, so the value of the acceleration will be more. So you can observe this sign from making it a custom. So if you will reduce this, the value of the acceleration will also reduce. So acceleration of the simple harmonic motion depend on the gravity in case of a simple pendulum. So you can observe this from this, and then the surface of the earth. Now we will introduce a bit of the friction. Now what will happen? Okay, in a normal view, the value of the acceleration is not changing. What is the reason? The reason is that the acceleration depend on the gravity. Okay, now the value we will observe is the velocity. Okay, let we go. Oscillate it. Velocity is always perpendicular to the movement of the acceleration because it is coming in outward direction. It is a 2D movement, so the velocity will act perpendicular to the direction of the acceleration. So this is the thing that as soon as, okay, once again, and we will observe it in a slow motion. You can see that the angle between the velocity and the acceleration are 90 degree to each other, because at main position the acceleration is directed towards the main position and this is the center of this the oscillation. So maximum acceleration will act in the upper direction, and the angle between the acceleration and velocity is the 90 degree. So I hope you got a good idea of this. And then we have done with related with the energy. Now we will move towards the next one, animations. uh, I have taken this animation from the walter-fendt.de, and I'm really happy that you also gave me the permission to use the animations. So let me start. Almost all the things are same, but there is some change in the graph as well. So there was no graphical motion in the previous one, so we will slow it down. Now you can see that the value related with the maximum amplitude is this one, and when it will move towards the main position, the fluidical mark, then the value is 0. Slow motion, we can use the slow motion factor as well. Resume. So you can get a very good idea related with this. This already we have done in the previous animation. This one we have done the amplitude, we can change the amplitude as well. Okay, now let we change the amplitude. If we will change the amplitude from 10 up to 5 and reset it and start, so it start moving. The time period you can see that is 4.49 seconds for this oscillation. So we have decreased the amplitude. Now amplitude is this one thing that reset 10. Okay, now we will increase the value of the amplitude. If can we increase it? Oh yes. Now start. So you can see that the vibrational area, which is the amplitude, has now increased. So we will make it towards the 20, reset 25 instead of 20, 30 please. Okay, the maximum value we can use is the 20. Okay, the other thing related with the velocity, the graph of the distance and time is starting from this position. The velocity is the reversal graph, which you already know from the textbook, that the velocity is the rate of change of the displacement. And then if we will talk about the acceleration graph is as well. You can see that what is happening in the start, and the same thing we have observed that the acceleration is always directed towards the main position. And then the forces. So if we will resume this, the direction of the force is towards the center. What is the reason? Because acceleration always acts in the direction of applied force. So the force is towards the center. So it means that the acceleration is also towards the center. Pause, reset, and energy. Now this is the graph, energy graph related with the kinetic energy as well as simultaneously the potential energy. So we will observe that what is happening. Now it start moving. The amplitude, we should set the amplitude up to 20. Reset amplitude 20. Okay, now start. So you can see that at one time the potential energy and slow motion. Now what is happening? Somewhere between the main position and this position, the potential energy and the kinetic energy are same. So now it's start coming back towards the main position. So kinetic energy start increasing, and when it reach exact at its main position, the kinetic energy is maximum and the potential energy is minimum. So I hope that you have enjoyed these animations, and I will make more animations lectures inshallah in the coming week. Take care.